Hi guys! Welcome to the enzyme series. There's 2 videos for the pre-lab for your enzyme labs because there's 2 different labs, and even though we're doing them both on the same day, you are going to have 2 completely separate labs in your lab notebook. So there's going to be enzymes part 1, which is what I'm showing you here, and then you'll have enzymes part 2, which is with the spectrophotometer. It'll be a separate video that will be posted right underneath this one when you get to that point. So to that end, hopefully before you watch this video, you have read the lab notebook pages 153 to 155. If you haven't, you'll still understand the video, so don't freak out, but make sure you do it before you come to lab. Specifically, I want to make sure that you get all the way down to, on page 135, the summary of the reactions that you're going to be working with in lab. For the purposes of our video, I made a little cheat sheet. So what we're going to be looking at today is we are investigating the role of the substrate concentration on the rate of reaction. And in fact, this purpose, I want you to delete the purpose that's in your lab notebook or the handout, and I want you to use this one instead. The one that's in your handout is not very good. It says to familiarize students with something. Get rid of that, and instead I want you to write in this one, because it's actually what you're going to be doing. So we will have talked about enzymes in class, so if you're watching this in advance of the lecture, this might seem a little confusing, but it'll be okay. We're going to have an enzyme plus a substrate yields an enzyme and a product. And we're going to remember that enzymes are the things that make chemical reactions happen faster, but they are not consumed in this process. And so in this case, we are just turning substrate, which you can think of as the reactants, into products, and the enzyme is unchanged. And so really what we're looking at is to investigate the role of the substrate concentration. What we're saying is when we change the concentration of the reactants, what's going to actually happen to the rate of reaction. So we're using the enzyme peroxidase. Peroxidase is found in peroxisomes. You probably remember that from Unit 2 when we did cells. And it's found in pretty much all living cells because H2O2, hydrogen peroxide, is a byproduct of a lot of different biological chemical reactions, and it's very dangerous for organisms. And so because it's so dangerous for organisms, we have to have a way to turn that hydrogen peroxide into something safe, like water and oxygen gas. And so the job of the peroxisomes is to turn that H2O2 into water and oxygen. So we're going to use 2 different sources for peroxidase in this series of labs. For this part 1, we're going to just use yeast, and I will have cooked it, if you will, put it in warm water when I got in this morning so that it has plenty of time to become peroxidase. And so we have our yeast peroxidase, and then we're going to add our substrate to that, H2O2, hydrogen peroxide, and what we're going to be left with is peroxidase plus water plus oxygen. And now, of course, this is going to be the gas. And so because we are producing a gas, as we're doing this, we're going to see bubbles form. And it's the formation of those bubbles that's going to allow us to monitor the rate of reaction. Okay, so here's what we got going on. You're going to get a piece of, this is actually chromatography paper. It says filter paper in your lab notebook, but this actually works just the same way. And in your inquiry tub, you'll find a hole punch. There are not forceps in your inquiry tub because I use these for my other class too, so don't put these back in your inquiry tub, give these back to me. But what you're going to do is you're just going to hole punch a bunch of holes, okay, and I got like miles of this stuff, so don't worry about being too frugal with it, but you're going to hole punch a bunch of them. You want to be pretty consistent with size. If you end up with one that's on the side like this, don't use it, but that should be one of your constants. And you're also going to need a 50 milliliter beaker. And in fact, if you want to get 2 or 3 beakers, if you have enough of them in your inquiry kit, you may not. You can get all of your substrate at once if you would like. And you're going to be measuring 3 different things. You're going to be measuring your control is going to be your DI water in your beaker, and then you're going to be measuring 2 different concentrations of substrate. Now, the substrate, again, is hydrogen peroxide, and so I have hydrogen peroxide just bought from Target. When you buy stuff, hydrogen peroxide just from the store, it is a 3% solution, and if you read the container very closely, it will tell you that. It tells you that right there, 3% solution. And so when it tells you to get 40 mils of 3%, that's just straight out of the brown bottle. I also took some and diluted it down to 1.5%, and so when it tells you to get 40 mils of 1.5%, it should be prepared like this. If for some reason you go over there and there's not any 1.5%, you can dilute it down yourself. It's not hard because you're going to be getting 40 mils of each one, so to cut this 3% down to 1.5%, just get 20 mils of this, and then to bring it up to volume of 40 mils, and you're good to go. Or you can tell me, and I'll make some, just usually that involves you waiting around for a little while, and that sometimes can be a bummer. So I went ahead and preloaded 1.5 mils, or 1.5% hydrogen peroxide into my beaker. And then I've got my forceps, and I grab one of my discs. I will have my stock solution of yeast somewhere in the classroom. You can just pour a little bit of it in the bottom of one of the little cups. You really need very, very little of this, so just a tiny bit will get the job done. So it tells you in your directions to dunk it in the yeast solution for 5 seconds. The whole goal behind that is to make sure that it has enough time to soak the paper through. And so give it a 5-second count, and then you pull it out. And now what I like to do is I just touch the disc to the side of the container so that any excess just comes off. Then this requires a partner, and in fact you guys should be working in a group of 3 or 4, so this shouldn't be an issue. What you do at this point is that you have your substrate here, and here's your enzyme. As soon as these two make contact, your reaction has started, and so somebody has to be timing this. You, with the forceps, are going to release your disc in the middle of your substrate, and it's probably going to sink to the bottom at first, but then as oxygen is produced, as this reaction is happening, the oxygen is going to be produced right here where the reaction is occurring, which is on the disc. And so bubbles will accumulate, and then it will rise to the surface. And so for us to measure the rate of the reaction, you're going to measure how much time it takes for it to go back up to the surface. If it sinks first, that's okay. You're just measuring how long it takes to get back up to the surface. So let me show you. I'm going to get it real nice and close. I am going to release this in the middle. If it sticks, just shake. And it sunk to the bottom, and that's okay. And then we just wait and wait and wait. And then as bubbles accumulate, and you probably won't be able to see the bubbles accumulate right at first. There it goes. It's going to go right back up to the surface. And so once it hits the surface, that's when you stop timing. And that is how long your reaction took. So to that end, you're done. And you're going to do 5 discs of the DI water. You're going to do 5 discs at 1.5%. You're going to do 5 discs at 3%. And so you did not get a data table in your lab notebook this time, because I want you to design one yourself. It needs to be neat, it needs to be organized, it needs to have all the necessary parts. You're going to remember down here that it tells you what your data analysis is going to be, so don't be confused about that. So you're going to do the data analysis as indicated. There's a lot of number crunching with this first part, and then you're going to write me one conclusion statement about the role of substrate concentration. And that's it for part 1. Separate video for part 2 that's coming up next. Thanks for watching. I'll see you again in a second. Bye.